Question number 59, we have the following. We've got an axle with two 2-kilogram balls hanging at each end. The rod is 50 centimeters long and of negligible mass. The rod is free to rotate in a vertical plane without friction above a horizontal axis. It's initially at rest. A 50-gram wad of wet putty drops into one of the balls, hitting it with a speed of 3 meters per second and sticking to it. A, what's the angular speed of the system just after the putty wad hits? To solve A, we need to use angular momentum. What kind of angular momentum does the putty have? The answer is we're using the MVR perpendicular. At the end, it's going to stick to it, and the whole system is going to rotate. We're dealing with I omega. So plugging in, first of all, the clay's angular momentum before the collision is just its mass, 50 grams, times the velocity, which is 3, times the distance, half of the length of the rod, which is 0.25. That's the distance it's from the pivot point. And that's going to equal the rotational inertia afterwards. Now, the trick to this one is the rotational inertia is both the rotational inertia of the two green masses, which is going to be 2 times 0.25, plus the other one, sorry, I had to think for a second moment. The other one, which is now going to be 2.05 because it's got the clay stuck to it. Distance is still 0.25 times the final omega. Sorry, for a second there I thought I did the wrong way. If we solve this then, total rotational inertia 0.253, total angular momentum beforehand 0.0375, and if we solve it then, the final omega of the system 0.148 radians per second. Question B, what's the ratio of the kinetic energy of the system after the collision to that of the putty just beforehand? To do that, we're just going to do a ratio of the final kinetic energy, which is going to be all rotational kinetic energy, compared to the original, which is all just regular linear kinetic energy. Plugging in our numbers, rotational inertia from up above was 0.253. Angular velocity just from the previous answer, 0.0148. And then beforehand, the mass of the putty was 50 grams or 0.05 kilograms. This velocity was 3. And if you solve that, you get that. Dividing it, that's our ratio. 99 or close to 99% of the energy is lost as E-dis during this collision. Finally, last one. Through what angle will the system rotate before it momentarily stops? Well, what's going to happen? The clay is going to hit this thing's going to swing, and eventually it's going to swing up until it briefly stops up here somewhere. The clay now stuck to it. We can figure out the height of that piece goes above that midpoint. Now, please remember each of the green masses is 2 kilograms, so we don't have to consider the change in GP of those, or gravitational potential energy, because there is no net change. It's just going to be the height that this piece of clay goes to. So what we're going to do in this case, and then from there we can find theta. Rotational kinetic energy can be converted into gravitational potential energy. The rotational kinetic energy from just up above here was 0.00278. And notice here we're only doing the mass of the clay. It's the only thing that's actually being lifted. And we can actually solve for this H part here. If you solve for the height, it's very small. It's about 0.5 centimeter. Not a lot before it's going to stop. And then finally, from that, we can do a little bit of trig. If you think about this as a right angle, the sine of theta should equal h over the hypotenuse, which is going to be the length of this rod, 0.25. We can solve for theta. And if you do that, you'll discover that theta is 1.80. But, quick reminder, remember the rod started out here. It went all the way through this 180 degrees before it went up through here. So therefore, the final angle that it's actually gone through is 180 plus that, or about 181.3 degrees. That's probably way too many sig figs, but you get the idea. Good luck. Hopefully this makes sense. Talk to you soon.